B reads as follows. Assume the current spot price is 1500 shillings per bag of wheat and the effective monthly interest rate is 1%. The monthly storage cost for wheat is 40 shillings per bag. Calculate the 3-month forward price for a bag of wheat. One thing that you need to take note of is that the storage costs begin from the date you entered into the contract. So if it's a 3-month contract, it will be from day 0, from 0, month 1, month 2, like that. So that is a 3-month period over here. So month 1, month 2. So this represents a 3-month forward in terms of the time horizon, like that. So this one will be a 4-month, this will be when it goes from over here up to period 2, that is for 3 months. This is for 4 months, for 5 months, for 6 months, and so on and so forth, like that. What am I saying? Putting it into perspective, we can look at we can first of all start by computing the storage costs. We can say we're looking at B. We can say calculate the future value at time t of storage costs. How do we go ahead and do that? We have been informed that the storage cost per bag of wheat is 40 shillings. We need to compound that. So we can say 40 into 1.1 plus R, or rather we can say when you're trying to compound, the general formula is A into 1 plus R power N, like that. So the storage cost, we are saying it is going to be 40. This is A, represents the storage cost, to 1 plus 0.1 power 0 plus 40 into 1 plus 0.1 power 1 plus 40 into 1 plus 0.1 power 2. This is for 3 months because the storage costs begin from the period from day 0, from right now. For example, 3 months moving forward, we are saying that we're going to conclude the storage costs from today to period month 1 and to month 2, like that. So this is a 3-month storage cost computation, like that. Where are we getting the 0.1 from? You can see the effective monthly interest rate has been given there as 1%. So actually I've made a mistake. This should be 0.01, 0.01, 0.01, 0.01, like that. So that is the required rate of return, or R component, which you're seeing is the monthly interest rate there. So putting it all together, we compute. So this one, any number power 0 is just that number itself. So this is 40 plus, now we have 40 multiplied by 1.01 power 1. We're saying 40.4 plus now 1.01 squared, 40.804, which is how much? That plus 40.4 plus 40. We have 121.204. That is the total storage cost. Now, what we need to note is that the forward price is given as the spot price, like that, multiplied by an exponential if it is continuously compounding, times risk-free rate times T, where F forward price, then S naught is spot price, then RF risk-free rate, moving on this other side, T is time. Moving over on this other side, we can be able to now apply this E. E is exponential and refers to continuously. compounded factor. There. But now in this case, since it is not continuously compounded, we can be able to just apply this simple formula that says, so we have 1500. So like in this case, is it 1500 or 1600? Let me just confirm that. We are saying we have now this general formula will be the 1500 like that now, because it's not continuously compounded like that. So we apply now, we grow it for 2 months. 1 plus 0.01 for how many periods? For 2 periods. That, for 2 periods, plus this component over here of lambda, which represents the storage cost. We've already computed the storage cost right over here, and this is the total storage cost that has actually been computed for, has been grown or has been compounded for the next 3 months. So what do we have? We have now 1500, 1 plus 1.01 squared plus 121.204. How much? We have 1500 times 1.01 power 2, or squared rather. Sorry, 1500 multiplied by 1.01 squared. We have 1530.15 plus 121.204, and the total value comes to how much? Plus 121.204. We have 1651.354. That is what we're saying. We expect the price to move from 1500 to 1651 over the next 3 months there. This is how commodities pricing is actually done.